This conversation is powered by Google Illuminate. Check out illuminate.google.com for more.
Hey everyone, welcome to our discussion on the basics of states of matter. We're diving into a really fundamental concept in science, something you probably learned about in middle school, but we'll be looking at it with a fresh perspective. What are the main states of matter and what are their key characteristics? Well, the three main states of matter that most people learn about are solid, liquid, and gas. Think about ice, water, and steam. All the same substance, water, but in different states. Solids have a definite shape and volume because their particles are tightly packed and strongly attracted to each other. Liquids have a definite volume but take the shape of their container because their particles are closer together than in a gas, but still move around more freely. Gases have neither a definite shape nor volume. Their particles are far apart and move around randomly.
That's a great start. So solids hold their shape, liquids take the shape of their container, and gases spread out to fill whatever space they're in. But what's actually happening at the particle level to cause these differences?
It all comes down to the forces between the particles and how much energy they have. In a solid, the attractive forces between particles are strong, and the particles have low kinetic energy, energy of motion, so they vibrate in place. In a liquid, the attractive forces are weaker, and the particles have more kinetic energy, allowing them to move around and slide past each other. In a gas, the attractive forces are very weak, and the particles have high kinetic energy, moving rapidly and independently.
Okay, so it's all about the balance between attractive forces and kinetic energy. What about temperature? How does that play a role?
Temperature is directly related to the average kinetic energy of the particles. Higher temperature means higher kinetic energy. So, as you heat a solid, the particles gain enough energy to overcome the attractive forces and transition to a liquid, melting. Further heating can lead to enough energy to become a gas, boiling, or vaporization. The reverse processes also occur with cooling.
So heating increases kinetic energy, weakening the attractive forces, and leading to a change of state. That makes sense. Are there any other states of matter besides solid, liquid, and gas?
Absolutely. There are several others, though they might be less familiar. Plasma is a state of matter where electrons are stripped from atoms, forming ions. It's often found in stars and lightning. Then there's Bose-Einstein condensate, a state where atoms behave as a single quantum entity at extremely low temperatures.
Wow, plasma and Bose-Einstein condensates. Those sound pretty exotic. Are there any other factors besides temperature and pressure that affect the state of matter?
Yes, pressure plays a significant role. Increasing pressure forces particles closer together, which can favor the solid or liquid state. Conversely, decreasing pressure allows particles to spread out, favoring the gaseous state. The specific conditions at which phase transitions occur, melting, boiling, etc., are described by phase diagrams.
Phase diagrams, that sounds like something we could explore further in another discussion. For now, let's recap. We've covered the three main states of matter, a solid, liquid, and gas, and how they relate to particle behavior, temperature, and pressure. We also briefly touched upon more exotic states like plasma and Bose-Einstein condensates. Thanks for joining us.